Emostel.
Hi, you're welcome again to this video, continuation of the journey from where we started. So far, we have done 12 classes. This is the 13th one. And in this class, on this same course, Mass 102, we are going to be talking about the projection of one vector on the other vector. Follow me. All right, so let's assume that we have two vectors. This is a point, a fixed point, all right? So this is one vector, this is another vector from O to B. Then O to A, one vector, O to B, another vector. Now, let's say that there is a particular line. There is a particular line at one point, all right, that leads from B towards A in such a way that it forms 90 degrees. Like it becomes adjacent 90 degrees to the vector OA. And then let's assume that there is a particular line also from the vector OA such that when you trace it down, okay, to the second vector OB, it will land at a particular point where the line from the end of that OA makes 90 degrees. That is, it becomes perpendicular to that vector OB. All right. So that particular point where one vector, a line from one vector lands on the other vector such that it will form a perpendicular relationship with the other vector, that is an angle 90 with the other vector, that particular point is what we call the projection of the vector on the other vector. All right. So as we have it here, it says the projection of vector A, that is vector OA, on this OB, okay, is represented or is given by the formula A cos theta. And the whole thing starts from, if you look at the trigonometric relationship that produced this, look at this. Cos theta is given as adjacent over hypotenuse. Cos theta is adjacent. If you check this very well, this is angle theta. The adjacent is always the line that carries the angle and also the 90 degrees, the right angle. Okay, that side is called the adjacent. Then the side that is facing the right angle, that is the 90-degree angle, the side that is facing it is called the hypotenuse. While the side facing the line or the side facing the angle theta is called the hypotenuse. We've discussed this in previous lessons. Okay, so now if you check it out, cos theta, which is adjacent over hypotenuse, will give us this length between O to M, the length OM, all right, from here to here, which is the projection of A on B, all right. Okay, so it will give us adjacent over hypotenuse. The hypotenuse is the whole of OA, the length of OA. I'm not talking about the vector OA itself, but the length of that vector, the magnitude of that vector. That is the reason why I'm putting it inside bar, to show the magnitude, okay? So not the magnitude of the vector, that is the numerical value of the vector, is what this length represents. And so that's the reason why we put it in form of what? Of magnitude, okay? So now the magnitude of vector OA is here, is representing the hypotenuse. Okay, why it's representing the hypotenuse here, the side facing this angle. Why this one is what? The opposite. So if you know the so-called car means cos theta is adjacent over hypotenuse. That is CAH. All right, and as you can see, the adjacent is OM, the hypotenuse is the whole of the length of OA. So at the end of the day, by the time you cross multiply, you have it that the projection of vector A on B, that is, which is represented by OM here, the length of OM, is equal to what? When you cross multiply, you have OA cos what? Cos theta. And that is what you have here. That is what bettered this formula here. All right. And on a similar note too, if you consider this second triangle, this ONB, this triangle here like this, the same relationship will produce this second formula. All right. I just don't want to take time going deep into it, but at least you've had the peripheral, and then because you really need to prepare for your exams, and then this lesson is dedicated to your exam prep. All right. So now that you know how we got the first formula, it is the same pattern that we applied, but using the second triangle here to get the second formula. All right. So if you want to memorize it, just understand that the projection of vector A on B is given as the magnitude of A multiplied by cos theta, which means that the thing that is projecting on the other vector, okay, is what we will write out. The magnitude of the vector projecting on another vector is what we multiply cos theta. Okay, you see that the vector that is being projected on is not even appearing in the formula at all. If we want to force it to appear, okay, since we know that the magnitude of a unit vector is always equal to 1, if we want to force the other one to appear, all we just do is we just say magnitude A multiplied by what? The magnitude of the unit vector of B, then cos what? Cos theta. Some textbook will write the formula like this. It is still the same. All right, because the magnitude of a unit vector is always equal to what? 1. It's always equal to 1. So 1 times A is still boils down to this. That is if you want B to appear. So which means that the thing that we are projecting upon is the one that comes out as unit vector. While what is projecting on something else is what comes out as what? The vector, the magnitude of the vector. So which means that A is projecting on B. So the projection of A on B is going to be magnitude of A multiplied by cos theta. If B is projecting on A, then the projection of vector B on A is given as the magnitude of B multiplied by what? Cos theta. So that is how it is done. So what is projecting on the other is what we fall into the cage of magnitude, then multiplied by the cosine of the angle between the two of them, and then you are good to go. You see that? So in your examination, you possibly, just in case you don't have a calculator, you should know the value, the fundamental value of the angles of some of these vectors, some of these, like for instance, what I'm trying to say is that you should be able to know offhand the value of cos 30 degrees, cos 45 degrees, cos 60 degrees, cos 90 degrees. You should also be able to know the value of sine 30 degrees, sine 45 degrees, sine 60 degrees, and sine 90 degrees. And then also, you need to know the value of tan 30 degrees, tan 45 degrees. These key angles, tan 60 degrees and tan 90 degrees. All right. All of these angles are most likely to be the angles that you'll be working with in order to save you the stress of using calculator. All right. So all these two have been addressed in a previous video. And then let's just move on, please, because I'm just like, this thing just came to my mind that I should just bring it out to you. So you guys just check it out, get the value of all these angles, and it will help you a lot. Okay. Don't focus on don't focus on the decimal value. Try to get their value in roots. Okay. And all that. So if you don't know them, or if you want to have them, just check it out. Just they will be attached to this video. Just click on the link below, and then you follow through with them. So just try and work with them, memorize them, and be able to use it. All right. So we quickly move on. All right. Then okay. So now that we know about that, this is the first set of formula on projection of vectors. First set of formula on projection of vectors. Now, the other set of formulas on projection of vectors is this one here. That is, if you are given vector, maybe they gave you vector in this kind of form. It is easy to apply this formula. You see, the question gave you the vectors just in form of unit vectors. The question did not supply you with the angle between the two vectors, but yet they want you to find the projection of a vector on the other. If that kind of question comes up, this is the formula to apply. I would have just really gone all my way trying to prove to you how this formula came to be. It's very easy. It's also generated from this A cos theta and blah, blah, blah. Then by applying the product rule, the dot product, sorry. And at the end of the day, you arrive at this conclusion. All right, it's a very simple and straightforward something, but I don't really have the time now. Okay, we want to record a lot more videos to cover this course before the exam, so you can just quickly have something to study and then you move on. Okay, so later on we could have extensive class for this, probably for the sets that are coming afterwards. All right, so we quickly move on. Then this formula is best applied when you are not supplied with the angle between the two vectors. So just like this example we have here. Okay, if you want to apply this formula now, you need to know the angle between the vector so that you can do the cosine of that angle and multiply by the magnitude of A to get the answer. But that is not applicable here. Okay, so here, since this one contains no angle, so you just apply this. So let's quickly work with this example here. We have example A, all this, example B, all this. It says find projection of A on B. So projection of A on B is going to be the dot product of A and B divided by the magnitude of the vector that is being projected upon. You see that the reverse of the case here. In this case, now A is projecting on B, so we find the magnitude of A multiplied by cos theta. But in this case, A is projecting on B, so we find the dot product of A and B and divide the result by the magnitude of B. That is magnitude of the vector that is being projected upon. Now, here too, B is projecting on A, so at the end of the day, A that is being projected upon is what goes to the denominator, so we find magnitude of A. That's the opposite of what happened here. And then we do the dot product. Very simple, straightforward, and that's it. All right, so now we quickly do all of that, and then we move on. So let's quickly do the dot product of A and B because we're going to need it in both cases. So we have A dot B. We know from the previous video, it's going to be the product of the sum of the product of the components of A and B. So the component of the X component, the Y component, the Z component. So the X component here is 2, the X component here is 1 because there's an invisible 1 here since it's only I the root. So you just write 2 times 1, then plus the X component here and here. You have minus 3 times 1 plus the Z component, which is what? 1 times 2. So you get that at the end of the day, you have 2 times 1 is 2 plus minus 3 times 1 is minus 3, then plus we have 2 times 1 is 2. So at the end of the day, we have 2 plus times minus is minus, okay, 3 plus 2. And then we have A dot B is equal to 2 plus 2 is 4, so 4 minus 3 is 1. So which means the dot product of A and B is equal to 1. So we are going to need that in each of the case here. All right, so the question says find projection. Let's find the magnitude of A and magnitude of B and then apply it to answer the two questions. So I'm going to take off this one now. All right, can I All right, so yeah, we got this. The dot product of A and B is equal to 1. Then we need to find the magnitude of A and magnitude of B. So let's quickly do that. The magnitude of A is going to be equal to the square root of the sum of the squares of the components of A. So that's going to be 2 raised power 2 plus minus 3 raised power 2 plus minus 1 raised power 2. Okay. Yeah. And then at the end of the day, we have it as the square root of 4 plus 9 plus 1. And then that happens to be 491 14. The square root of 14. So let's find the magnitude of B. Magnitude of B is going to be the square root of the sum of the squares of the components of B, and that's going to be 1 squared plus another 1 squared then plus 2 squared. Okay, so we have it as square root of 1 plus 1, like 2 raised power 2 is 4, 5, 6. So we have the square root of 6. All right, so now say therefore the projection of A on B, the projection of A on B is going to be A dot B divided by the magnitude of B, right? So which is 1, the answer we got earlier, divided by the magnitude of vector B, root 6. That's the answer. You can use calculator to get the decimal. Okay, then the projection of B on A is going to be equal to what? A dot B divided by the magnitude of A. And then at the end, we have 1, which is A dot B, and then divided by the magnitude of B of A, and that's root 14. And so you can also use your calculator to get the final answer, and that is that as per that. And so we come to the end of this topic called the projection of vectors. You can practice some more questions to master it, but never forget these two formulas. This one, the formula 1, and then the formula 2. Remember the difference between the two formulas, and then you get it. Although, okay, let me just use this as a giveaway for those who didn't actually get this before. Let me give you the list of, in this video, let me just include this here instead of you having to follow a link. Let me give you the list of the trigonometric ratios of special angles that you are most likely to come across or to use in this journey. Okay. So just take this as a bonus. All right. You will see that there is a relationship between cosine and sine. All right, they meet at one point, and then the opposite begins to happen again. Okay, so we have sine theta, we have cos theta, tan theta, okay, 0 degrees is a special angle, 30 degrees is a special angle, 45 degrees is a special angle, 60 degrees is a special angle. There are some beautiful things that happen around these values of angles, and that's the reason why we call them special angles. All right. So I'm sure if you are not going to be allowed to use calculator, the kind of questions they will set for you will be questions that require only the use of these special angles. You get that? And so when you can make use of these special angles, then I don't think you really have issues. You just apply their values and then you are good to go. All right. So now, sine 0 is 0. Okay. Cos 0 is 1. All right. And then, sine is equal to cosine, tan theta is equal to sine theta over what? Over cos theta. And so that's going to be equal to what? 0 divided by 1. Okay. And that is simply 0. So this one too becomes 0. All right. When it comes to 30 degrees, all right, sine 30 degrees is given as 0.5, which is half. That is 1 over 2. You understand it now? Why cos 30 degrees? Why cos 30 degrees is given as root 3 over 2. And then if you want to find tan 30 degree ends up becoming 1 over root 3. Okay, 1 over root 3, because if you divide them like half divided by root 3 over 2, it's going to give you half. This division will change to multiplication. Why this one will go up and this one goes down? That's the rule in maths. Then we have 2 over root 3. Okay, when division changes to multiplication, then the denominator, the ratio of the denominator will switch. So 2 cancel 2, and then you have 1 over root 3. So that's how we got this one. All right. And so that is that as per that, sorry. And then when it comes to sine, when it comes to 45 degrees, cosine and sine, they overlap. You understand? That is, they are the same value, and the same value as 1/√2. Yeah, 1/√2. And then 1/√2 divided by 1/√2, then this one is what? Is 1. You see that? Then when it comes to 60 degrees, they switch. The value of sine here becomes the value of cosine. And then the value of cosine becomes the value of sine when it was 30 degrees. You get it? And they switch. So when it comes to, like, sine 30 degrees is half. So cos 60 degree is half. What cosine was when sine was 30 degrees is what sine will be in 60 degrees. And what cosine was when sine was 30 is what it to be in 60. You understand? I don't know whether I'm saying what is right anyway. That English is even confusing myself. So, like, what I'm just trying to say is that when we're dealing with 30 degrees, sine theta was half. So when we are dealing with 60 degrees, cos theta will be half. Then they will switch. That is, the thing here will switch here, while the thing here will switch there. So we have it as what? This one now is √3/2. All right. So, well, as usual, tangent is this over this. So when we have √3/2, okay, divided by 1/2, it becomes √3/2 times 2/1. 2 cancels 2. So this one is just ordinary √3. Okay, now we are going to experience another switch again. You know, sine 0 degrees is what? Sine 0 degrees is 0. Okay, they will also switch. Cos 0 degree was 1. But when it comes to sine, when it comes to 90 degrees, all right, sine 90 degrees is 1. Cos 90 degrees is 0. And then, 1/0, that is what? Anything divided by 0 is infinity. It's undefined in mathematics. So 0 can be divided by any number, but no number can be divided by 0. Okay? Any number divided by 0 is what? Is infinity. So that's the reason why they say tan 90 is infinity. The thing goes to 180 and so, but they just stick to this one. Because by the time we begin to enter 180, then we are talking about this quadrant something. Okay, we begin to check whether it falls in the first quadrant and all that. Then some of these values become negative and all. So I don't want to really go into that because that is not what we are doing now. So this is a bonus for those people who didn't learn this with me before. You can just memorize all these things. It's easy to memorize. Okay, if you just follow the rule, the switching rule, and just remember the key ones among them. And then remember that tan is always division of sine and cos. And you can be able to fill up the table yourself and then use them in any question that you come across. So that marks the end of this particular video. See you in the next video as we move into another main topic, which is the cross product of two vectors. All right, see you then. Bye.